In this lesson, we're going to be talking about motors. Okay, and we're going to start off with the basics. We're going to talk a little bit about the windings. We're going to talk a little bit about the insides of the motors, and we're going to go into the most basic part of the motor, which is called the shaded pole motor. Okay, motors consist of a stationary part called the stator that surrounds a rotating part called the rotor. One or more windings are mounted on the stator. There's no windings in an AC motor on the rotor. So when we take a look at this, the parts of the motor, we have the housing. If we break open the housing, fixed into the housing is the stator. Then we have a rotor, which if you look at it closely, if you ever pull one apart and take a look at it closely, it will have little magnets on it. That's connected to the shaft. This part rotates inside the stator. The rotor, or the center part of the motor, is not connected to any external source of voltage. When the winding on the stator is powered, it generates a magnetic field. As the AC changes from a positive to negative, this magnetic field will, what we call, rotate. It's going to constantly be changing direction, as in it will have one part of it will have a north charge, the other part of it will have a south charge, just like a magnet. But 60 times a second, that is going to change direction. Okay, now let's get back to magnets for a sec, because this is the whole center portion of how motors work. Like poles of a magnet will repel each other, unlike poles will attract. So as this motor is alternating poles here basically on the stator, the magnet on the inside is going to constantly be trying to drive itself away from like poles and towards unlike poles. So if north and north is lined up, it's going to drive itself very quickly to north and south being lined up. But then all of a sudden the magnetic pole changes so that what is now north is now south. So this is going to constantly be spinning to try to get itself so that north and south are together, but not north and north. Okay? As the magnetic fields of the stator windings change from a positive to a negative, it chases the rotor, as the poles on the rotor are also positive and negative. This constant change in the magnetic field is what keeps the motor running. Now, there is a small problem with this whole thing. It comes up when you're trying to start a motor. If the magnets are lined up evenly between the poles, the motor's not going to start. So for this reason, some motors, and more frequently than not, have what we call a start winding. Okay, when you take a close look at the stator, remember that's the fixed portion inside the motor, you have a run winding, which is made of some pretty thick wire, and there's not a lot of it there. But you'll also see a start winding in most motors. That start winding is a bigger bundle of thinner wire. The additional winding in a single-phase motor that allows the motor to start is the start winding, when the poles of the stator and rotor are not in the correct position. The current applied to the start winding is slightly out of phase with that applied to the run winding. What that means is that because of the start components like the capacitor, the start winding north and south, or positive and negative, will not be in the identical location as the run winding. So by being out of phase, I may now all of a sudden have two north poles in that motor that now has a better chance of pushing that magnet on the rotor into its new position and get the motor start to turn. The run winding on the stator is the one that allows the motor to continue to operate. The run winding gets constant voltage until the motor is shut off. The start winding does not. Okay, now we have the most basic type of motor that we're going to start off with, and that's called the shaded pole motor. The shaded pole motor has one winding surrounded by a laminate core. It uses a shaded pole to determine its rotation. The shaded pole motor consists of a squirrel cage rotor, an iron core, 2 or more rings with poles and with a coil and a small copper insert. What this copper insert does, it slows the buildup of the magnetic field just enough to cause rotation towards the next magnetic field. Okay, this action provides for induced magnetism into the rotor. The rotor will then turn if it's attracted by magnetism. Movement of the rotor will continue as long as there's a change of polarity of the poles of the rotor. If the motor stalls or if the bearings freeze on a shaded pole motor, the motor is just such low power that it will not burn out. When a motor is in a locked condition, the winding draws very little current. The direction of a shaded pole motor is always towards the shaded pole. Shaded pole motors can be made multi-tap by inserting voltage taps onto the motor winding. Shaded pole motors they're very low in cost, but they have what we call a low starting torque and a very low power factor. They cannot drive heavy loads, and they also cannot start a heavy load. They can't handle much more than a fan blade. This is an example of a shaded pole motor. The wiring diagram is really easy. It's one coil. That's all it is. And you just label it motor or whatever you want to label it. Okay, now when you look in a shaded pole motor, we have our stator, which has the windings around it, but one side of that stator will have a copper band. Remember that little copper band we were just talking about that helps move the rotor in the correct direction. And this could be L1 and neutral. This could be L1, L2. You could also have some additional voltage taps in here that allow you to have low, medium, or high as well. So, again, motors have 2 parts we're really worried about. We have the stator, which is the non-movable part with all the windings. We have the rotor, which is the movable part with the magnets in the center. And the stator, when energized with alternating current, builds up a magnetic charge that actually forces those magnets on the rotor to continuously rotate so that north and north are never together. Start windings have way more wire than the run winding, and shaded pole motors only have a single winding, but they have a copper band that helps move the motor. Okay, the shaded pole motors are built for very small sizes and are used for light duty and small appliances. In refrigeration, shaded pole motors are frequently used as evaporator fan motors and condenser fan motors. So that's it. That's it. Shaded pole motors, 2 wires, very easy to work with.